I am Brad Keelor. He is Krishna Kumar. Coming up next on Director's Cut, you're going to find out how he uses murder mysteries to teach geotechnical engineering.
I've got shot through a space not too long ago. I thought I knew the place so well. It wasn't the same, now it goes to show. Sometimes you never can tell.
Hello again, everybody, and welcome to another episode of Director's Cut. My name is Brad Keelor. I'm the director of the Geo-Institute, and that is why we call this show Director's Cut. Every single week, except during the summer, we'll hear more about that later, and 1 week at the holidays, I sit down with a different Geo-Institute member who has stories to tell. Some of them are personal, some are professional, but all of them we bring to you every week are fun. If you don't know anything about the Geo-Institute, after you watch this here interview today, use your favorite device, use your favorite browser, or maybe one you don't like, that will work too, and go over to geoinstitute.org. There you will find out so many things about us, including that we are a technical society with about 12,000 members, most of whom are geotechnical engineers and or geologists, and that we are part of the American Society of Civil Engineers. And if you like what you see today, and this is episode like 226, I think. If you don't like what you see today, we have a problem. Maybe we should change the show format. But if you do like what you see, you should click like, subscribe, and get notifications, and we will let you know every time we post something to the YouTube channel. Coming to us from Austin, Texas, where he is a faculty member at the University of Texas at Austin. It is Krishna Kumar. Krishna, welcome and thank you for doing this.
Yeah, thank you, Brad. Thanks for having me.
We're going to have a good time today. As if the murder mysteries weren't enough, we have lots of other great stuff to talk about. We have 10 questions, the same as we do every week, and 2 of those are the same that we ask everybody. We start with one of those. Describe your job in 45 seconds.
All right. So here on Earth, we dig with these massive 50-ton excavators that can move mountains. But my work is on the moon, where the gravity is 1/6. So these giant machines would literally bounce around like toys and be impossible to control. My work is at the intersection of robotics, geotech, and AI. We use massive supercomputers at the University of Texas at Austin, TAC Computing Systems, to create these lightning-fast virtual environments for the robots to play around, generally struggle through millions of attempts, but being done in minutes so that it can learn to adapt to real-world scenarios. So in one line, my job is basically teaching the next generation of engineers and robots to be smart about dirt, where the dirt can be either from Texas or on the moon.
That is amazing. And, we have so many of those things that we're going to talk about at different parts of the interview. I have one comment and then one follow-up question. I have a lot of stickers on my new laptop that I just got a couple of weeks ago. One of them is from TAC. It's one of my favorite stickers of all time. The text says, "My other computer is super." I don't know if you've ever seen this one because it's pretty old at this point. I'm going to guess it's close to 15 years old, but it's cool. I want to ask you about the moon. You brought that up pretty early on there. When did you start thinking about it? Because I feel like for a lot of people, this is not something that comes in late in life. What was the first time you were interested in the moon, and how cool is it that you apply your current geotechnical work on the surface of the moon?
I think, like, as a kid, I always wanted to do, like every engineering kid, like we wanted to be a scientist. I wanted to do robotics. Yeah. I wanted to be an astronaut and sometimes also dig for dinosaur bones. And I think being a geotechnical engineer and being a faculty member has allowed me to do every single one of them that I've published in virus evolutions and studying viruses. So that's close to digging bones, I guess, to applying it for robotics. So just because you end up being a geotechnical engineer, it just takes longer. But robotics, one of the big challenge is soil, because most of the robots are designed to go on hard terrains, and having them go on these soft terrains is extremely hard. And my research kind of evolved over time from doing simulation work to AI and machine learning. Now I do optimization, and Moon is a perfect challenge for that, where it's so many thousands of miles away from us. There is a time lag, so you need autonomy. So everything I'm phrasing as the Moon is the grand challenge, where all those technology can actually be brought back to Earth and do make geotechnical engineering a lot more fun and exciting and autonomous too.
Oh, it's a great answer. And again, we're going to get to some of this other stuff throughout the course of the interview. Of course, if anybody has seen Director's Cut in the past, you know what we're famous for. We won all those Emmys for a reason, right? It's those hard-hitting questions that we ask. Krishna, we're going to start with this one. People should consult their calendars. Maybe meteorologically it's not summer yet, but it's June 17th as we record this. It's summer. Krishna, what's your favorite summer food?
I think my favorite is watermelon. I always look for that, wait for it at our HEBs to see watermelons out. And mangoes are two big summer fruits that I'm really excited about. Coming from India, we don't generally get those type of mangoes here, but I'm still like very fond of the mangoes we get over the summer. And I can just keep eating watermelon all the time.
So let's transform this into Mango's Cut here for a minute, and tell everybody, I mean, what kinds of mangoes should they be looking for from South Asia if they can get them? Because I know I get excited when I go into the H Mart or whatever Asian grocery store sometimes and see the mangoes from Asia, but I'm not as familiar with the varieties as I am for the ones that come from the Americas. So what should people be looking for a good mango that comes from Asia?
I think this probably is a name very local. I'm not sure if we will ever get it in the US, but it's called like Alfonso mangoes in my state from India. But the closest one I ever got was the ones in Costco here. So they are very tasty, and I really like those ones at Costco too.
I'm always amazed how Costco, like, you know, you can talk all the trash about Costco you want, but you just gave them big ups for their mango selection. I read a thing the other day where somebody reviewed all the different types of hot dogs, the big brand hot dogs that are available, and Costco won the taste test. This is unbelievable how they do this. It's whew. We may get on a little more food on Director's Cut later. That's what we do here. But the third question is always the research question, and today will be no exception. You mentioned the video simulations early on in the interview, and I think that's what we're going to talk about now. How did you get into doing this video simulation work, and can you talk about some of the applications that are coming out of the work that you're doing now?
Yeah, I think this was after a discussion I had with one of the NASA directors at the Kennedy Research Center, Robert Mueller. He is actively involved in the ASCE programs for the space. And we were talking about it, and once he realized I was a geotechnical engineer, he said, like, your material is really bad. And that's when I thought, it's like, okay, in space, after all the rocketry and things that we learn, they really can't deal with soil. That's how difficult our material is. And he was talking about some of the cold domes that are going to go up for lunar missions. And one of the challenges they have is trying to measure the soil properties just by using a bucket and scooping it. And he said, oh, we have 2 cameras. That's all we have. Can we measure soil properties? I was like, it varies a lot, and it depends a lot on the initial densities. They don't have all our typical tests. We can't even do a plate load test or a cone penetration test. So he was like, well, we can scoop up in a bucket, pour it, watch it. Can you figure out what the material properties look like? I was like, okay, let's use that as a challenge and start building it. And recently there are technologies like Gaussian splats that have been coming out. You may have seen some generative AI where DALL-E is great to go from text to images. What we do is we go from images to 3D models. So if you give us an image, we can basically build a 3D model. So if you give us a sequence of images around different objects, we will be able to do what is called a splat, which is a 3D reconstruction of the object using points and rendering, and that allows us to build a full 3D model. But 3D models are not really useful because you can always construct 3D models with just planes and boxes. What this allows us to do is we can add physics to these blobs. So suddenly the 10 years of my material point method and my experience in Gaussian splat and rendering collided with each other. Now my Gaussian blobs can deform like a soil. So all I have to do is record a video, create a 3D model. So think of it like your NPM point or even discrete element model points, but we are going to deform your video based on the physics we know. So that means I can have your initial state in a video and fully deform it, and it will look as realistic as the real video because you're literally deforming the video elements in the system. This allows us to measure forces from videos. So imagine like just excavating something, and I will be able to tell how much force that was applied to be able to deform that. Or even in the case of NASA's work for the moon, we're trying to use this idea to explore what is the friction angle for the soil or cohesion for the soil just based on looking at videos. So when people say seeing is believing, we're saying like seeing is how we're going to measure soil properties and maybe even simulate from there and teach the robots how to interact with these environments.
So I think a lot of this probably makes sense to people as they hear the words, but you really have to kind of sit back and think about it to understand how foreign this environment is when you're talking about anything lunar, right? We've explored so little of the lunar surface. We've explored even less of the subsurface, and in some cases we've gone down a couple of feet maybe with any kind of probe or whatever.
And we're trying to even have a lunar habitat soon. So it's not like we're going to have CPTs suddenly all over the moon so we can measure the properties. And a lot of it has to do with vision. So we will eventually have robots roaming around on lunar surfaces. They're just going to look at it and they need to decide if they need to go over this rock or go around it or excavate it. And it needs to be able to do a little bit of movement and figure out what is happening, get the feedback. So a lot of this vision to simulation work is driven by that fact. But it also can be applied for BIM, which is used a lot in construction. So imagine flying a drone, and instead of doing photogrammetry, you now have an interactive 3D building model, which you can deform, play around with, apply forces. I even had undergraduate REU students do this, where they will just type in text, create a 3D model. They always hit everything with tsunami. I gave them a fluid simulator, and they were like, look, we made a Japanese pagoda temple, hit it with a tsunami. It's like, we made a house and hit it with a tsunami. But that's it. Like, you now went from what was LLMs to now you can just talk and say, build, like, look at this video of a bridge, hit it with a tsunami, but they forgot to tell which direction the tsunami for a bridge is coming from. So instead of the water rising under the bridge, the water in this case hit from the side on, like a car going on the bridge, because they forgot to tell the LLM which direction the tsunami will come. And LLM couldn't figure out, hey, there's water underneath the bridge. That's what's going to cause the tsunami. So it's a great evolving field, and there's lots of potential applications for it.
I don't know what it is that's appealing about the destruction in those cases, but as someone who's old enough to have played the original Sim City as a kid, there was a scenario where you could unleash Godzilla on your city, and there was a scenario where you could blow up a nuclear power plant and have to deal with the aftermath, and both of those were really, really good, and it was kind of fun to rebuild from those. So maybe that's what it was, but yes, the extreme destruction was kind of a lot of fun. Krishna, you're getting some good questions this week. Before we recorded, I explained that I was in line at Walmart the other day to return something, and someone was trying to return a half empty box of diapers. And I could not imagine any scenario where this needed to happen. Like, I don't know. I am the parent of two kids. I can't think of a scenario when they were small and in diapers that I would have had to return a half a box of diapers. Krishna, what questions would you like to ask people that you would never actually ask?
Uh, this question I wouldn't ask anyone unless I really, really trust them. This is not my own question, but I really liked and embodied this question. This question comes from Richard Hamming, who was a great scientist, and he worked at Bell Labs. He would go sit in different departments' lunch tables and ask these questions. So his question was basically, what is the most important problem in your field? And by itself is not a difficult question. That was the question you would ask the first week. The second week, you would go, this is the kicker. Why are you not working on it? So I think like asking this question, I want to ask it to every researcher is like, I'm just because I'm curious, like from their perspective, what they think is the most important problems. And he defines important problems are not like teleportation or time travel, but solid concrete problems that need to be solved right now. And if we don't work on these important problems, we will never do important work, is his mantra. And I really like it. And I've asked it to a few people and have had great answers. But it's a very dangerous question to ask to anyone just like that.
Yeah, I can see how it would you'd either blow the person off and be like, psh, or it would make you question everything about your life to that point, possibly, right? Like,
Right.
I mean, because by the time somebody's gotten a PhD and spent several years in a field, it's kind of done. You've gone down that road, and that's what you're working on, right? Oh man, that's a really good one. Wow. Oh, and we have a visitor. We birds cut this week. Mangoes, birds. That was just in time too, because I know you have birds. We have a bird at home. Bird people, as my wife says, are a little quirky and yet all very similar, right? In a lot of ways, right? Krishna, how did you first get a bird as a pet?
So my wife really liked birds, and that's how I got into them. We got budgies. We had a few of them, but they were really nice, but they kept to themselves. So we wanted slightly more exciting ones. So the one who came here is Jay. She's a recent mom, got 3 babies, all 2 weeks old. So they've been part of my life for the last 2.5 years, and they've been inseparable. I've been in almost every single Zoom meeting I've had during COVID. So I've been a pirate or pretend to be one for almost the entirety of COVID. It's been fun having them around. And in boring meetings, if they start to fall asleep, I know I'm boring them. So there is a good marker for me when I'm teaching a Zoom online class.
Do you agree with the assessment that bird people are quirky?
I guess so. We are quirky. Like otherwise, they all have. We were talking about their characters and character per unit ounce.
Yes.
For something that weighs about 80 grams, they have a huge character. They want certain things a certain way. They're picky in particular way, and they're adorable and friendly and loving creatures.
And I think it's it's kind of like with music, right? When you meet somebody that listens to the same music as you, if you're really into music, you kind of like freak out internally and you're like, I can't believe this. Like, I just met this person. Having a bird is kind of the same way. You meet another bird person and you're like, oh, I have so many questions I want to
Yeah.
ask. Like, it's like you can't get them all out at once. Has that been your experience?
Yeah, I've been like discovering so many things. Did not even realize like male birds are the ones that sing, like mine whistles. Learned two songs, September, Earth, Wind, and Fire, and Cookie. And I didn't even know I had a female until she laid an egg, and I was like, "Oops, I have a female bird." So now finally have babies. So it's been a learning experience. You never know what they like, what they don't, and the things they do. It's having real babies, kind of like.
That is amazing. Oh, I'm glad that we haven't had a bird question on Director's Cut in a long time, so I'm glad we were able to do that. The other question we ask everybody when they come on the show is your ASCE history. How did you first get involved in ASCE and then GI?
Yeah, I think moving from the UK, I'm also from a granular physics group, so our conferences have been small. I think my first ASCE conference was in Minnesota. So just before COVID, and that was um, shocking for me because I've never seen such a huge conference before. My conferences have been about 50 people or 35. So seeing about 1,000 people in a huge auditorium to have industry, academics, students, competitions going on, that was overwhelming, enjoyable, and I could see how big of an event that is for ASCE. So as soon as I was back, I was the GI student coordinator and have been involved with the GI Austin GI student chapter. Been part of it for the last 4 or 5 years. Attended every single geo-congress, and we recently had the Austin GI chapter open up. Like that's been a month old. And we just had an interaction last week where talked about AI. So it's been phenomenal how much it helps the students. And I can't appreciate that enough and how big Geo-Institute is in fostering the students' interest in geotech, having these competitions and allowing them to present at these conferences.
So I mean, you've been doing this now, you said, for 4 or 5 years. Well, I guess if you went to Minneapolis right before COVID, now it's over 5 years. What's the most rewarding thing about being involved with the GSO for you?
I think talking to the students has always been the most rewarding. Tell them like, yeah, I didn't have a plan either. So like they all see faculty as someone who knows exactly what they've done and they know about their research, which we end up eventually knowing a lot about. But during that process, it's something that we are struggling, we are learning and talking to them, having crazy ideas from them because of course, undergrads and grads have these crazy ideas. We kind of hit them out as we become older and become faculty. So it's always fun to listen to students and track with them. Go listen to their conference poster presentations is the most exciting part for me because they're new. They want to share their ideas to the world, and that's a great platform that I enjoy listening to and supporting them.
That's amazing. So this is our pitch to our viewers today. For all the students out there, join your grad student organization at your university. If you don't have one, we'd be more than happy to help you create one. It is really easy. All you need to do is fill out a form and find a faculty member who will support you, like Krishna, and you're all set. It is that simple. We would love to have you and your GSO in the GI fold. The question we teased at the beginning, all these episodes of Director's Cut, and every now and then I think to myself, I never thought we'd be talking about topic X or Y. I can honestly say I never thought we would talk about murder mysteries and geotechnical engineering, and yet here we are. Krishna, you're teaching a geotech course that uses murder mysteries. I mean, tell us a little bit about the course, and then we're going to talk about what led to it. But first, we got to know about the course period.
Yes, it's a required class at UT. It started third year, and we have about 150 students. And I'm the person who is standing between them and their graduation. So yes, geotechnical engineering is fun and exciting, but not everyone who is graduating like semester wants to be a geotechnical engineer. So I wanted it to be fun, exciting for everyone. So went down to the core idea of like, what is engineering? And engineering is about problem solving. So if I can teach them how to come up with a way to problem solve, or a tool set of like, here's how you approach any problem, and give them a safe environment to try and fail, no answer is bad. And that how like the murder mystery kind of evolved into this program, where I wanted to make it exciting for the students, interesting before we get to do the fun settlement calculation, consolidation analysis, and even designing foundations. So we have the initial abstract portions where we are talking about volume relationships. We are doing Atterberg's limits. I need them to have some context, like, why are we doing this? Can I make it interesting? And that's how it started for me. I think it was just before COVID when I taught this class.
So the question I asked before we started recording is if you were interested in true crime or crime dramas or anything like that, what was your answer to this?
Nope. Like I've seen some movies, maybe some Hitchcock films, but I'm not into true crime dramas that much. So this totally came out of the blue because one day while I was asked to teach a 15-minute class on effective stresses for a job interview, it's only 15 minutes, and I thought, I will try a different take for this. Why don't we teach effective stresses to, they told me these are first year undergrad students, not your typical second or third year students. So I didn't want to show them equations. I wanted them to understand what soil behavior would feel like. So it started out with, can I answer questions like, everyone's a geotechnical engineer, and I have a picture of a kid playing on the beach telling, what is the amount of water content that you need to add to build a perfect sandcastle. To when in doubt, always ask your dogs, because dogs are really good at digging shallow pits. And why do they dig shallow pits? And that was the question the effective stress was trying to answer. And one other interesting question was, can I build an underwater sandcastle and keep it upright? And will that be taller or shorter than the one we would build above in normal air conditions? So that led me to this idea of like, oh, I can actually teach soil mechanics without showing them equations. Can we fundamentally rethink how we teach any engineering class, which has some abstract concepts before it get into concrete problems? My inspiration is Professor Malcolm Bolton's book on Guide to Soil Mechanics. That had an interesting example, which opened up more or less like a forensic case history. But I tweaked it a little bit to make it murder mysteries, which makes it everyone excited. Students want to know. So essentially, it's forensic case history, but I treat it like murder mysteries. No one usually dies, except for some couple of bad examples, but it's been fun teaching it this way.
That was an important point there, that nobody dies in there. Now I do have to ask, this is the logical question to close this out with. Has this influenced your TV watching or your podcast listening habits at all? Are you now into any of that stuff or not at all?
Yeah, absolutely. Like I now watch a lot of how to make movies. So there are episodes like Lessons from the Screenplay on YouTube or Nerdwriter, because it's about storytelling, and I'm trying to think of like, how do I do an effective story to convince people, keep them excited. And I now feel like teaching and making a movie is almost similar. You need to get your readers along. Don't reveal everything. They need to figure things out by themselves while keeping it interesting, fun, and engaging. So there was a period where I was reading a lot of how to do screenwriting. So I had people ask me, "Is like, wait, are you going to go?" This was before I got tenure. They were thinking, "As like, oh, I'm going to change my profession and go become a screenwriter." It's like, no, I'm trying to teach geotech by learning how to make good movies.
Oh, that's great. I love that. Good life lessons there for everybody too. So we weren't going to make it through the whole interview without talking about high performance computing. And I think one of the things that surprised me, now it's been 9 years, but when I started at ASCE and GI, was how relatively little the civil and geotech were using HPC compared to a lot of other disciplines. And I mean, that's changed a little bit, but I feel like in the HPC pie, civil is still a really little part of it. Why shouldn't civil or geotechnical engineers be intimidated by high performance computing?
I think that high performance computing, the software stack has changed a lot. So when I did my PhD back in Cambridge, GPUs were very new, and programming those needed CUDA. Now, with all the explosion of machine learning, what it has made is made physics-based simulation really easy to do just using Python. You don't have to learn complex tools like MPI, how to communicate across nodes. Python can handle a lot of that for you. There are also nice interfaces like DesignSafe here at UT Austin, which gives you a graphical user interface to use these HPC-enabled tools. So you don't really need to learn a lot about high-performance computing while leveraging all those HPC tools. I think the biggest selling point is Python has made it a lot easier. You can now leverage these HPC tools to do big problems. One thing I'll always remember, this is from my advisor, PhD advisor, Kenichi Soga. Professor Soga is now at Berkeley. He was previously in Cambridge. And I was really excited back in 2010 when I did a coupled lattice-Boltzmann discrete element simulation. I think I had about 100,000 fluid nodes and 150 discrete element particles, and showed a really nice animation and showed to Professor Soga, is like, Kenichi, look, this looks great. And he was like, yeah, that's not enough number of particles. And that kind of kick-started my GPU and high-performance computing world. And we now have 50 million points to billions of particles simulating a landslide like Oso. We have a 50 million material point simulation. And you go back and say, it's like, now I have 50 million or a billion particle. And he went like, a billion particle is 1,000 grains by 1,000 grains by 1,000 grains in 3D. That's a billion. That's a cubic meter of soil. We are trying to study landslides, which are kilometers long. We are no way close to doing this in HPC scale. So in a lot of ways, this HPC is really untapped and is the best. Geotechnical field is the best area where HPC can blow up and show new worlds. We can look at particle scale, what's happening, to look at regional scale impacts. I think there are a lot of tools out there right now that will help you ease that transition. And machine learning, if you're doing that on Google Colab or anywhere else, you're already using these GPU. You just weren't aware of it. So I think with more training, so we have through our programs as well, like there are a lot of online free trainings that we give out through DesignSafe and Shishiki. So leverage it if you want to learn about machine learning or high performance computing. Yeah, I think that gives you a whole lot of things to simulate and make things better.
Another amazing sales pitch. People can learn so much today. We have 2 summary questions to close, and one of them is, of course, to promote something that GI is doing this summer, Krishna, that you're involved in. We'll get to that in just a minute. First, one of the questions that I love to ask when we get around this time of year is a very simple one, plays into the nostalgia, but there's something special about summer, the way that those memories stick in your head, I think. So what is your favorite all-time summer memory?
Um, I think this is during COVID. But summer is when I got my birds and I also got married. That's my best memory.
Oh,
It was the summer of, I think, July 2021, where we were organizing the hackathon for the NERI hackathon. I got married and I was writing my career proposal and had all my birds. All of that happened in July of 2021 in 3 weeks. I think those are the best part of my life and the craziest part of my life over the summer. So July somehow turns to be extremely fun and crazy for me, yeah, all the time. Like,
oh, that is amazing, and not that long ago. So you can relive that every day, and I guess you do in a lot of ways too. That's good. So we said we were going to talk about what GI has coming this summer. And in case you missed it, Director's Cut is going to take a break the same way we always do in July and August. And we are always looking for something amazing to fill those Wednesdays until we are back in the fall. Last year, we did a 7-part series of relatively basic geotech talks on different topics called Summer School. It was such a big hit that we decided to bring it back this year. We've got 7 new topics, 7 new speakers coming up starting July 9th, and we'll go all through July and August every Wednesday with those. Krishna, you are going to do the machine learning and AI one. I mean, I don't know that that needs any more hype. I think people are going to be pretty interested to hear about that. But what are you looking forward to the most about your summer school episode?
I think like explaining how machine learning work in a way of demystifying it. Like we need to understand how machine learning works to be able to use it effectively. So I'm interested in showing them like push pull the curtains away and show what's happening behind the scenes, because these are black box models and I want everyone to use them, but they are like numerical methods but extremely dangerous. You always get colorful plots in numerical methods. Machine learning will always do colorful plots way more quickly and way more crazily. So I'm interested in showing why it works a certain way. Can we explain why it made a particular decision? And more importantly, can we bring physics into our machine learning models? So we've had hundreds of years of history of starting from effective stress all this way to all our simulations that we're doing right now. Bring all of those physics into our machine learning models so we have the cake as well as eat it too in some way. So accelerate things while being correct is what I want to emphasize when we do machine learning.
It's amazing. So people are going to want to look out for that. Again, those will be starting Wednesdays in July. July 9th will be the first episode, and Krishna's will come along not too long after that. I think for the final question here, I do want to ask you one more. You mentioned about explaining machine learning to the audience. Are you surprised that in 2025 you still have to give the level of explanations that you do about that? I mean, I know there are constantly new developments and stuff, but I think when you get embroiled in any field and you're using it day to day, I think it's always a little bit surprising to see what's outside, right? Maybe that fewer people are using this, but specifically with this one, I'm surprised that machine learning and AI had the takeoff curve, I guess, the adoption curve that they did, and that they're not more widely used. What about you?
I think the Chat GPT was the revolutionary moment for many people, but it kind of also comes with its own quirks in a way, because it hides even more things behind the scenes. Like, is it actually memorizing, or is it reasoning, or is it actually thinking? Like, there are a lot of research that goes into that, and we can talk about it for ages. Sometimes, like, we have these reasoning models, and recently there were papers that were saying was like, they can only reason up to the amount of memory it can hold, and it's probably not actually reasoning like a human would reason. So understanding what it does is very important. And my big concern right now is, right now, when people say machine learning or AI, everyone thinks, oh, ChatGPT, and how ChatGPT is going to solve it. And the big thing is, like, geotechnical engineers, we need to be building tools like we did for numerical methods when we did finite elements. This is not an OpenAI's job to go build tools for us. And I want our geotechnical engineers to build tools which the AI models can leverage and make our work faster, verifiable, and correct. And for that, it goes back to the HPC question. It goes back to murder mysteries, is what is the fundamentals of engineering? That won't change no matter what AI we have. And we still need to teach that. We still need to have critical understanding of how every tool that we use works in order to give the best engineering decisions for our clients.
That is a perfect answer and a great way to sum up. And I think the takeaway there, at least for me, is that you can't forget thousands of years of engineering just because some new shiny thing came along. It's another tool in the toolbox that you have at your disposal that might make you learn how to do some things differently or more quickly, but you can't forget everything that came before it. So, Krishna, you survived all 10 questions and the follow-ups, and it was fantastic. And we got some more bird action here. What more could you ask for from an episode of Director's Cut? For our viewers, if you liked what you saw, and you probably did because you're here at the end, again, click like, subscribe, and get notifications. And yes, we'll let you know every time we post something to the YouTube channel. Unbelievably, we only have one episode of Director's Cut left before our season 6 summer break. This is crazy. I can't even believe that it's summer 6, period. But that is the truth, so you'll want to be here next week for that, and then enjoy summer school when we pick to that in July. So, Krishna, thanks again for doing this. I hope it was a good time.
Thanks, Brad. It was really fun and enjoyable. Thank you so much.
And again, for all of our viewers, we will see you one more time before summer next week with a brand new episode of Director's Cut.